welcome back. I hope you have polished off the millionaire shortbread and the fudge brownies outside. They were very, very Moorish. But we have a compelling reason for you to come back and back into the main tent, and that's because we're now going to turn our attention to hydrogen, the subject that we all think we know something about, but really secretly don't. And so it's my very great pleasure to welcome Alistair Dutton back onto the stage, and I'm going to ask Alistair to introduce his guest, and they're going to have a fireside chat, just ranging as far as they want to on the subject of hydrogen. Thanks, Alistair.
Thank you very much, Adam. I think I'm mic'd up. Yep, that's working well. Harry, come on off stage.
Thanks.
Most of you were here when I was introducing myself, so I won't go through it again, other than offshore wind's my thing, and I'm a Global Wind Energy Council. Harry, rather than me introduce you, how about you introduce you?
Okay, hi everyone. My name is Harry Varmadevan, and I'm the Regional Director of Energy Systems for DNV.
Nice and simple. So we're here to talk about hydrogen. I'd welcome some questions or comments from the audience, but we'll kick it away. So DNV came up with a net zero report very recently, which looks at a number of different things, but hydrogen is a large part. So what would be your key takeaways?
We publish a few reports, and the first report, the Energy Transition Outlook, takes all the current projections of technology and policy and NDCs, the nationally determined contribution, and comes up with a global warming of 2.3 degrees by 2050. So patently not good enough, and we then turned around and said the only game in town is 1.5 degrees. What do we need to do to deliver 1.5 degrees? And that was fairly simple. We're running out of time. We need to scale electricity and renewable electricity. And that's the main theme. And if we don't do that, which for an offshore wind audience that you've been talking about all afternoon, if we don't achieve that, then all bets are off. We will not achieve 1.5 degrees. But if we manage to scale up massively renewables, both solar and wind, including onshore and offshore, then you get to a sector that is hard to electrify. Aviation, maritime, heavy transport, a lot of heavy industry, an element of domestic or industrial heating. That's still a little more controversial. How do you address those? They need an alternate path to net zero, because you cannot electrify them. And the only alternative path to net zero for those sectors is hydrogen. There's a little bit of discussion about CCS, and we can explore that, but really hydrogen is that main. And what was amazing is from the original report that forecast 2.3 degrees and the current projections, not including anything that's happened for the last couple of days, hydrogen is really negligible in the energy demand picture for 2050. It's something like 3%. In the 1.5 degree scenario, with this massive scaling up of renewables, it meets almost 15% of the energy demand is met by hydrogen. So that's an incredible change if we're going to achieve the 1.5 degrees, and that's really where the compelling argument for hydrogen starts to come in.
So people talk about the three colours of hydrogen, grey, blue and green. I understand in Brazil they have 8 colours of hydrogen. They differentiate between biomass and nuclear and all those things. But we're clearly not with what we call renewable hydrogen rather than green, because that's, some people claim to be green who aren't renewable. So I'll use the phrase renewable hydrogen. But the current hydrogen usage is not, it's from fossil fuels. So what's the journey into renewable hydrogen? Give us a feel for how it's going to happen, and something about the scale and timing.
It is a challenge. If you think about the challenge that offshore wind is meeting, it's the production of electricity. Where hydrogen gets concerned, you've got two problems. You're trying to create the production, and you're trying to create a demand for hydrogen. So you're actually doing both sides of the energy system at the same time, and it's very hard to do it at the same time. Yeah? And the green hydrogen story requires that massive scaling up of offshore wind, because first you need to meet the electricity demands, and then you can start to use it to do something else. So in the meantime, how do you create a hydrogen economy? Well, you need to move the demand, and you need to have some supply while offshore wind and renewables are scaling up and the green hydrogen story comes in. And that's when you get the multicolours of hydrogen. And to be honest, at DNV, we've looked at pretty much every different colour. My favourite is pink from nuclear. There's purple from biomass. There's yellow, I think, from recycled plastic. But actually, the big one at the beginning, joking aside, is the one that's a little more controversial. And that's the use of blue hydrogen combined with CCS to get the hydrogen economy moving. Why is it slightly controversial? Because there's schools of thought about CCS extending the life of fossil fuels. And if you're going to go for a massive scaling up of renewables electricity, if you start to extend the life of fossil fuels, that's where the debate comes in. But in reality, and this is really where DNV is, this is a technology-driven energy transition. And you need to embrace those technologies that allow you to move quickly. Most of the green hydrogen is 2040 and onwards. If you wait till 2040, our original assessment of today's commitment shows the 1.5 degree budget gone by 2029. So the greatest difficulty we have today is that time is the enemy. So to get things moving is where the other colours of hydrogen come in. So we can build a hydrogen economy and meet a demand straight away and then allow the green hydrogen to come in.
And the other challenge is cost. So the figures I'm hearing, I'm not trying to be an expert on this bit, is we need to get below $2 per kilogram. And we're currently at something like 6 for renewable hydrogen. So how do we get that cost down? Because that becomes the compelling case rather than the regulatory case.
Yeah, there's two sides to the cost. One is the cost of the technology, and there's a cost curve. I mean, you saw it in offshore wind. We've been there for the last 20 years as the price has come down, to the point now the lowest cost of electricity is renewable electricity. But that's on the back of 20 years. EV cars, following a very similar pattern. Within a year to 3 years, the cheapest car will be an electric vehicle. Yeah? Again, on the back of a 20-year cycle. The problem for hydrogen is we don't have a 20-year cycle to wait because time is running out. So one is trying to accelerate that technology curve, but the second side, which is really when you're trying to, and that's what the report really talks about, we're flipping the energy system at its heart. So today's, and I like to say yesterday's, energy system is 80% fossil fuels, 20% non-fossil fuels. The energy system of the future in 2050 is 80% non-fossil fuels, 20% fossil fuels. And one of the drivers behind what makes it so complicated in deploying technology is the whole process of incentivization and taxation. From one country to another, you might find a tax benefit for one technology that is actually subsidized, and it's actually penalized in another completely different country. So the whole incentive and taxation of the energy system is really quite messy. And that's what makes things quite, like the UK government was very proactive on offshore wind, put in mechanisms. So if we're really going to both have the cost curve accelerating, we also need policy. Yeah? And things like the carbon price does need to come in and be a little bit more consistent at its value, because it's quite inconsistent at the moment. And on our analysis for 1.5 degrees, it's an $80 carbon price per tonne. That's what's needed, because at that point, you start to get a true cost of the fossil fuels. It then makes hydrogen and CCS investable, and also makes the renewables electricity absolutely the cheapest cost, and you get that injection. But that won't be enough for green hydrogen. That's just the starting point. Green hydrogen will need a similar mechanism that offshore wind had around the contract for differences, yeah, where the government sets, there'll be a strike price, and then everyone else comes in and gives their best estimate, and whoever is the lowest wins, but then there is effectively a subsidy coming from government. So you'll need both the carbon price and that policy, but you'll also need, in the early days, some sort of contract for difference or some sort of incentive basis to get the green hydrogen, the fuel cells and the electrolyzers going forward.
So I was in conversation on Tuesday, and I've had a previous conversation with the UK government, and that's seriously being considered. I shouldn't say it's got past that point,
Sure.
But they can see how the CFD is perfectly applicable as an instrument, and it's become very successful in the offshore wind and other parts of the sector. So that seems a probability, I would say, just a matter of when. Are there any questions people would like to raise? Otherwise, I'll keep going. At the back, please.
Hi, I'm mic duty as well, but I'm Anna Dunbar from Mainstream. I have a question around the cost that you associate with producing hydrogen. If you say that it's going to be such a key driver, where do you see the position of hydrogen coupled with offshore wind compared to maybe some of the onshore renewables that are a lot cheaper? So where you have countries that are producing very cheap solar, very cheap onshore wind. Why does it have such a synergy with offshore wind?
The access to grid electricity, and that's one of the things we do explore. There are different ways to produce the green hydrogen in terms of electricity. So the grid itself, and especially there's an element of variable supply and demand, and therefore the cost of electricity can be quite cheap for quite long periods. So you can see grid-based electricity doing green hydrogen, especially in certain countries where sometimes, and I know the utility companies hate me saying this, but sometimes electricity is almost free in certain places in the world at the right time. So clearly that can be a driver, and you are seeing some green hydrogen projects in locations where you've got access to cheap grid electricity. So you're absolutely correct, that will be there. And when you look at that scenario in 2050, we do actually build it out into say there will be a significant electricity grid-based green hydrogen as well as offshore wind. I think where offshore wind is really interesting is the whole area of stranded wind. Yeah, and if you think about the evolution of from onshore to offshore, from fixed bottom to floating, it's a very similar evolution to oil and gas. Yeah, and the one thing about going out in offshore wind is scale. And the one thing that's missing in the energy transition at the moment on the renewable side, I would say, is scale. And by going offshore, you're able to get a lot more scale with projects that are bigger, and then hydrogen can be part of that. And that's one of the things I think going forward in the energy transition. We need to see much bigger renewables projects. Yeah? I've got a confession, most of my career is in oil and gas. Okay? And we're used to billion-dollar projects. Yeah, you de-risk them, you get the funding, and you create a huge amount of energy. Renewables needs to have more ambition and be bolder, because most investments, they don't like units of 100 million and 200 million. They like bigger units because it's the same amount of work to invest in a 50 million, 100 million operation than it is in a $1 billion operation. Yeah? So renewables, especially going offshore, you're able to get that scale. Yeah? And you can look at options. Yeah? And there will be options about putting an HVDC cable in, or making hydrogen and then putting it into a pipeline or shipping it. But all of these things are still being developed. But the simple answer is you're quite correct. There will be grid-based green hydrogen coming through in 2040, 2050. I think there was...
There's one in the middle here.
My old friend Nigel.
I think it was actually a very similar question. You might have just answered. Hello, can you hear me? Yeah, it was just really further on the technology. You've just kind of alluded to it. I was wondering about where the hydrogen gets produced. Is it going to be these big mega projects offshore, or is there a role for community projects providing the hydrogen locally through a local grid? So it's just any thoughts on that area?
Clearly, I think one of the challenges is that fragmentation. The advantage of grid electricity is you will produce the hydrogen very close to the consumer. Yeah. So if you've got some sort of industrial, domestic heating, as well as you can imagine hydrogen hubs, and that's something that's talked about. A hydrogen cluster where you've got an industrial use, a domestic use, you may have some CCS, and that starts to make sense. And my personal opinion is you will probably see hydrogen in quite a regionalized way for a while, until you get to a level that it becomes a global tradable commodity, and that also is going to take the form of liquid hydrogen. Ammonia is bound to play a part at some point, especially when you start to look at shipping.
There's one in the middle here, that's it. And one behind you in a moment.
Sorry. Hi, it's Norman Skillen from Yandernul. You say that timing is a critical thing here. You really need the action this decade rather than ahead. So you've got lots of projects around the UK who have all got grid challenges, ScotWind, for example, as well. So is there something that we can do to incentivize some of those projects just to go straight to hydrogen? I mean, Germany's announced a round that's purely for hydrogen. So why not do something like this in the UK? Maybe with a carrier for the hydrogen as well.
Yeah, I mean, you're quite right in this whole discussion of how to move these projects forward. But one of the things, and again, this is a reflection on my part than necessarily DNV, is I find the business model is actually a real struggle. So you see some of the results that have been announced by the turbine manufacturers, not making a huge amount of money. Yeah? So the business models to drive this don't seem to be there. And that's partly because the whole incentive and taxation of energy is actually really messy and really complicated, which means that you've got, and I sat on I joined a group last night where you've got too much finance and you've got lots of projects. But the two don't equate, because the financiers are saying these projects are too risky. Yeah? And in a lot of places, I know you've just discussed Latin America. But yes, we can say we can roll out renewables everywhere, but as soon as you go to certain countries, risk index goes up. Yeah? And the access to finance goes down. Yeah? So there is a business model element that I have to be honest, I haven't solved, because if I did, I probably wouldn't be working for DNV. But there's an element where actually how you make money and how you structure these projects. But I've definitely heard enough for the last 2 days to know there's enough projects and to know there's enough finance. We're simply not de-risking these projects sufficiently well for the investor community to go into. And they love big projects, and they love, you know, reasonably big ticket items that will have a global impact. So I think the appetite is there. We've just got to try to make it happen. But the simple answer is, I don't have a great answer to that.
Sorry about that. There was a question further back.
Actually, it's 2 questions. The first question, but I'll put them all as one question, and you can answer them separately. When you talk about stranded wind and hydrogen, what sort of size field do you envisage to be the minimum size for a hydrogen dedicated field or whatever? And then the second question is that you talk hydrogen will be used, but hydrogen as a vector, I mean, I presume when we're talking about, you prefaced it about aviation and marine. Hydrogen is kind of difficult to package up. Are you talking about hydrogen as a vector to create something like ammonia, or are you talking something differently?
There's an element of hydrogen for the fuel cell, the electrolyzer, without question. Yeah? And they are already established technologies that will evolve, and feeding them hydrogen comes out of one and goes into another to produce electricity. So clearly those technologies are there, and you'll be looking at the fuel cell for certain, perhaps heavy vehicles predominantly. And there's been some announcements you'll have seen this week, certain tie-ups between hydrogen production and hydrogen use. So that's one. The other is the direct burning of hydrogen as a power source. Yeah, for power stations. And there's a pilot in the UK, I forget which power station in the UK, they're looking at hydrogen. So that's one. So that's another area where it's direct for power generation. And then you've got the business of how you move hydrogen as a source for aviation and for shipping. And right now, storing and moving hydrogen is relatively expensive. And that's where the liquid solutions you start to look at, and that could be ammonia. But again, that's still an if. You know, that case has not been made. But if we're going to manage global warming and emissions to 1.5 degrees, we have no choice. And that's really what DNV looked at with this report, was to spin the problem around the other way. And not just to say, where will normal cost curves, where will normal policy evolution, where will it take us? Well, it takes us to 2.5 degrees, and it takes us to 1.5 degrees spent by 2029. That's just patently not good enough. And so I think the one thing that I was hoping to hear a bit more of this week is, and there's been elements of that, I think India's commitment to 50% renewables by 2030, deforestation by 2030, 30% cutting of methane from I forget how many countries by 2030. Now you wouldn't have expected that maybe a year ago. And I have to be honest, when we've set up at Spade Adam something called High Street, took us a long time to think of the name for that, where we're trying to repurpose the national grid gas transportation system, and we've taken elements of it to build it as a pilot and to see if we can move hydrogen through high pressure, low pressure, existing pipelines to a terrace of houses, and to see what the safety and efficiency challenges are around that. Yeah? So there's a lot of work going on there. And if you had told me 2-3 years ago, actually when I asked for money to do that, everyone thought, where's hydrogen 2-3 years ago? So it's amazing the speed of some of the commitments that are happening. And so I am optimistic that certainly something like green hydrogen, which looks still a little bit fanciful, yeah, is much more doable at scale. But I'd like to go back to where you guys were a little earlier. It only works if offshore wind is scaling, if solar is scaling. Yeah? If that's not scaling, well then green hydrogen doesn't happen, and we'll have a lot of other problems to think about.
Well, are there any other questions? Feel free. One over here.
Hi, Charlie Durant from CRU Group. You mentioned the fall, or in your models, a fall of costs from 6 down to 2. What do you think is going to be the most important driver to get us there?
I'm starting to forget elements of the report, actually, because there's a point at which you start to get slightly dazed by all the conversations you've been having after a few days. I think the carbon price, and DNV's been quite clear, a relatively, I say relatively because most of the time when you talk in conversations about carbon price, you tend to hear 30 to 50. Yeah, we're talking $80 carbon price. That makes hydrogen investable, CCS investable, and gives you that, I think, that tonic for offshore wind that makes it a much more investable proposition. That really is the starting point. The second is that whole business in government policy, and maybe I'd make this point, that, you know, energy systems are a national issue. Resilience and energy is a national issue. So to some degree, yes, industry, and we're part of that industry, but there is a cue from government. Yeah, and that cue from government has to be some sort of incentivization and taxation scheme that makes sense. And right now, at an energy system level, it doesn't make sense. So in one country, you've got relatively high carbon prices. In another, you've got subsidies to fly planes in as much as possible, right? Because they want tourists. Yeah. So there's an inequality of incentives and taxation, which also does need addressing. But really, we see carbon price as the way. But we also know that's not universally agreed, and unlikely to have that agreement at COP26.
So one question I've got is, and this may be a little fanciful, that's why I'm asking you the question. I hear people say, with hydrogen, we won't need to be connected to the grid, and therefore we can take offshore wind to lots of other places. And if you care to wander over the global wind atlas, you'll find certainly down southern Atlantic wind speeds of 14 meters a second, very common. And since wind power is the cube of the wind speed, that makes for some very interesting opportunity. And I'm presuming that hydrogen would go onto ships and then it can go pretty much anywhere. But is that too fanciful?
Not at all. It's amazing, Alistair, you raised that, because I'm just going to give a plug to an announcement that was made around 12 o'clock today with DNV and Aker Horizons. Yeah? And you've probably already heard the concepts of energy islands to produce hydrogen. Well, this is a combination of Aker and DNV has a long history in floating, whether it's vessels or whether it's oil and gas or other types. And so we've come up with a $23 billion floating in the west of Shetland to take some huge turbines, yeah, and to basically power an offshore hydrogen hub, which will then have different mechanisms to bring that hydrogen. It was announced this morning. I'd like to tell you I remember loads of stats, but actually they've all gone out of my head. But that's the kind of scale that we're talking about, because the wind power, the wind generation is massive. Yeah? But you're deep water, so you've got to float. Yeah? And so a combination of floating wind farms linked with a floating hydrogen hub gives you that scale of activity, and we've been using the Treasury's own calculations for how you value carbon and how you value the energy you produce, and it becomes a very investable item. And that's something I know that the Scottish Government is now also having some meetings about. So that's the kind of scale, and that's what energy is used to operating at that scale. Yeah? There are projects around the world that are multi-billion-dollar projects in energy, and so actually it's not fanciful, Alistair. It's exactly the ambitious future we need to have if we're going to stay to 1.5 degrees. And we should be clear about that. Sticking to 1.5 degrees requires a massive scaling up and a massive increase in ambition, which is why you end up with 15% of energy demand met by hydrogen in 2050. It is only in that 1.5 degrees that happens. If we do it in a nice incremental way, we'll be at 2.5, 2.7 degrees, and hydrogen will be a tiny part of the global economy.
So I didn't know about your announcement, so it's refreshing to hear that that is at least becoming a reality. And could that also then be liquefied onto ships to spread around the world?
Yes,
yeah.
There's no question. I mean, you know, DNV's got a long history in shipping, and there's no question shipping is looking at that, and that's a really important element to the decarbonisation of these hard-to-electrify sectors like aviation and maritime.
Okay, do we have any questions? I think we've got time for possibly one more. Here we are. You've got your own microphone.
Whenever people are talking about hydrogen at the moment, they talk about it as another energy vector for industries that cannot be electrified, so like transport and some other industries like that. Why is there so little conversation around using hydrogen to solve some of our longer term storage issues around the electricity sector?
Yeah, great question. And really, certainly storage comes certainly into it, without question. There's been big improvements in balancing the variability of offshore wind as for electrical generation, and both in terms of batteries and in terms of just managing a dynamic electricity system. I am at the limit of my knowledge at that point. So it has come on leaps and bounds, but clearly the ability to produce hydrogen and store it is part of that whole vector. But I think just producing, yes, you could do that if you were using the periods when electricity is very cheap, yeah, and then in fairly local solutions. But storing hydrogen is not straightforward, yeah. And yes, we've got a long history of storing natural gas and lots of other things, but storing hydrogen is more complicated and more expensive, and therefore that's why it's not coming in the short term as one of the solutions.
And one of the things I was hearing, there was a study earlier this year looking at where hydrogen was most value in use, and actually power generation was right at the bottom, if not the bottom, with lots of other higher value applications like industrial chemicals and all of those things.
It makes more sense to use hydrogen for things that you can't electrify. Yeah, if you can electrify power generation, electrify it, don't use hydrogen. There's a certain efficiency curve. You're just converting things. The more times you convert them, the more loss you have. So there is something counterintuitive to use hydrogen for that. But yeah, so I think it's important to recognize that we can talk about the hard to electrify areas, and then there is an element that suddenly if you have hydrogen available, plentiful and cheap, it will start to get used for other things. And I'd like to make a plug for the work the onshore gas grids, they are a big customer for DNV, are doing. In fact, that we are looking at hydrogen for domestic heating. Yeah, and we're looking at what it will take to put hydrogen by 2030, in the 2030s, and therefore why? Because electrifying 22 million homes, so 22 million homes are powered today by natural gas and 40% of industry. To electrify all of that in a decade is quite hard. If you've got hydrogen as part of that solution, it will make decarbonisation that much easier. So we are looking at it for other slightly more straightforward applications as well.
Thank you very much. That was a fast-moving fireside chat. We need to bring it to a close. So firstly, round of applause for Harry.